Have you ever looked up at the moon and wondered about its secrets? This celestial body hanging in our sky has captivated us for millennia, its mysteries as tantalizing as they are numerous. What is the moon made of? How did it come to be? These questions have sparked countless theories, each more intriguing than the last. From the fission hypothesis, suggesting the moon spun out from the Earth's early history, to the giant impact hypothesis, positing a colossal collision between Earth and a Mars-sized body, the moon's formation is a riddle wrapped in an enigma. Yet, merely theorizing wasn't enough. The thirst for lunar knowledge drove us to undertake one of humanity's most ambitious endeavors. To unravel these lunar mysteries, we embarked on a series of ambitious missions, the Apollo missions. In 1969, the world watched in awe as Apollo 11 launched into space. The significance of this mission cannot be overstated. It was a triumph of human courage, ingenuity, and the spirit of exploration. Apollo 11 was the first manned mission to land on the moon, a feat that seemed almost impossible just a decade earlier. As astronaut Neil Armstrong descended the lunar module's ladder, he uttered the now iconic words, "That's one small step for man, one giant leap for mankind." These words resonated across the globe, heralding a new era of space exploration. The Apollo program didn't stop there. It continued with Apollo 12, 14, 15, 16, and 17, each mission broadening our understanding of the moon. From navigating lunar landscapes to deploying scientific instruments, the Apollo astronauts carried out a wide range of tasks on the moon's surface. But perhaps their most important role was that of lunar geologists. They collected rocks and soil samples, which were returned to Earth for detailed analysis. These missions gave us a glimpse into the moon's past, its geological history, and the processes that have shaped its surface. The lunar samples collected during the Apollo missions revealed a surprising truth: that the moon's surface is not a barren wasteland, but a complex and dynamic environment. The Apollo missions were not just about landing on the moon, they were about discovery. They allowed us to see our celestial neighbor up close and personal, to touch its surface, and to bring a piece of it back home. They paved the way for future lunar exploration and inspired generations to dream of reaching for the stars. But perhaps most importantly, the Apollo missions showed us what we can achieve when we work together towards a common goal. They reminded us that we are explorers by nature, driven by curiosity and a desire to understand our place in the universe. And as we look towards the future, the spirit of Apollo continues to guide us, lighting the way as we journey further into the final frontier. The Apollo missions were not just about landing on the moon, they were about discovery. One of the key discoveries of the Apollo missions was about the moon's origin. Our celestial companion, the moon, has always been shrouded in mystery. Where did it come from? How was it formed? These were questions that had stumped scientists for centuries, but the Apollo missions of the late 20th century were about to change that. The prevailing theory about the moon's formation is a cataclysmic event known as the giant impact hypothesis. This theory suggests that about 4.5 billion years ago, a Mars-sized body, which scientists have named Theia, collided with the young Earth. The collision was so powerful that it sent a cloud of debris into Earth's orbit. Over time, this debris coalesced under the force of gravity to form the moon. The Apollo missions provided the first opportunity for scientists to test this theory. The astronauts' lunar samples were crucial in this regard. When these samples were analyzed back on Earth, scientists found that they shared many similarities with terrestrial rocks. This was a significant clue. The similarities suggested that the moon and Earth share a common origin, lending credence to the giant impact hypothesis. However, the lunar samples also revealed differences. For instance, the moon has a much lower concentration of volatile elements such as water, which are abundant on Earth. This suggested that the moon underwent a great heating event, possibly the result of a collision, which caused these elements to evaporate. The Apollo missions also discovered that the moon's crust is much thicker than Earth's, and that its core is proportionally smaller. These observations further support the giant impact hypothesis, as computer simulations of the collision predict these characteristics. The Apollo missions not only confirmed our theories, but also revealed the moon's stark differences with Earth. Through these missions, we have come to understand our moon not as a mere object in the sky, but as a dynamic world with its own unique history. And even as we continue to explore and learn, the moon's origin story remains a testament to the dramatic and violent history of our solar system. Unlike Earth, the moon has no atmosphere. This stark contrast between our home planet and our lunar neighbor is one of the most significant findings from the Apollo missions. But what does it mean exactly to say that the moon has no atmosphere? When we talk about an atmosphere, we're referring to a layer of gases that surrounds a planet, held in place by gravity. Earth's atmosphere is a life-sustaining blanket, providing us with the air we breathe, shielding us from harmful solar radiation, and helping to regulate our planet's temperature. Now imagine stripping all that away. That's the reality on the moon. It's not that the moon has absolutely no gases around it. Rather, it's that these gases are so thin and spread out, they can't form a proper atmosphere. This lack of atmosphere results in a landscape that is constantly bombarded by solar radiation, with surface temperatures swinging dramatically between day and night. But why does the moon lack an atmosphere? The answer lies in its size and its magnetic field. The moon is only 1/4 the diameter of Earth and has much weaker gravity. This means it can't hold on to an atmosphere like Earth can. Additionally, the moon has a very weak magnetic field, which is another essential factor in maintaining an atmosphere. So, what are the implications of this for future lunar exploration and colonization? Well, any long-term human presence on the moon will require protection against solar radiation and temperature extremes. This could mean building habitats underground or developing materials that can withstand the harsh lunar environment. Furthermore, the lack of an atmosphere means that any resources, such as water ice, that might be found on the moon's surface, are exposed to the vacuum of space. This presents both challenges and opportunities in terms of resource extraction and utilization. Understanding the moon's lack of atmosphere was a crucial discovery, but it was not the only one. As we delve deeper into the lunar mysteries, we continue to uncover fascinating insights about our closest celestial neighbor. The Apollo missions provided us with valuable lunar samples. These precious pieces of the moon, brought back by the brave astronauts, have given us a glimpse into the moon's past. Imagine holding a piece of the moon in your hand. These lunar samples, or moon rocks, are not just ordinary rocks. They're time capsules, preserving the history of the moon's geology and volcanic activity. By studying them, we've learned that the moon's surface is covered with a fine, powdery dust, known as lunar regolith. This regolith is formed by the constant bombardment of meteorites over billions of years. Beneath the regolith, the moon rocks tell us a story of intense volcanic activity. Some rocks, known as basalts, formed from cooling lava, are similar to those found on Earth. This suggests that the moon was once a hot, molten world, with flowing rivers of lava that eventually cooled and solidified. Other samples contain tiny glass beads, evidence of explosive volcanic eruptions. These eruptions were so powerful that they spewed molten rock high into the moon's sky, where it cooled rapidly to form glass. This discovery was a surprise, as it suggested the moon was not just a cold, dead world, but had a dynamic and violent past. These lunar samples also contain traces of helium-3, a rare isotope not found on Earth. Helium-3 could potentially be used as a clean, efficient source of energy in nuclear fusion reactions. This opens up exciting possibilities for future lunar resource exploration and exploitation. But the moon still holds many secrets. Even after 50 years, scientists are still studying these lunar samples, and with every new discovery, we gain a deeper understanding of our closest celestial neighbor. These lunar samples opened up new possibilities for resource exploration on the moon. Not only do they help us understand the moon's past, but they also give us a glimpse into our future, a future where we might one day utilize the moon's resources for the benefit of humankind. The exploration of the moon didn't stop with the Apollo missions. Indeed, our lunar odyssey extended far beyond those initial forays. The moon continued to be a beacon of curiosity, a celestial sphere of mystery that we couldn't resist exploring. In the years following Apollo, we saw the birth of a new era, an era of robotic lunar probes. These automated explorers, unencumbered by human limitations, could delve into the moon's secrets in ways we could only dream of during the Apollo era. They were our eyes and ears on the lunar surface, sending back invaluable data that helped further unravel the enigma of our celestial neighbor. One of the most significant breakthroughs came from NASA's Lunar Reconnaissance Orbiter. Launched in 2009, it provided the most detailed maps of the moon's surface ever created, revealing hidden features and possible locations for future moon bases. And speaking of moon bases, the idea of a sustained human presence on the moon isn't just science fiction anymore. Plans are underway for Artemis, a NASA program aiming to establish a sustainable human outpost on the moon by the year 2030. This moon base could serve as a stepping stone for future missions to Mars and beyond, making it a critical component of our future in space exploration. In addition to NASA, other countries and private companies have also set their sights on the moon. China's Chang'e program, India's Chandrayaan missions, and SpaceX's Starship are all part of this new lunar race. Each of these endeavors is contributing to our understanding of the moon, and each has the potential to unlock new discoveries and opportunities. As we continue to push the boundaries of our knowledge and technology, we are venturing further into the uncharted territories of the moon. Each mission, each discovery, brings us one step closer to understanding our place in the universe. As we continue to explore the moon, we are one step closer to understanding our place in the universe. The moon, our closest celestial neighbor, continues to fascinate us. As we journey through the cosmos, the Apollo missions and beyond have illuminated the path, unveiling mysteries that have puzzled humanity for millennia. The Apollo missions of the late 1960s and early 1970s marked a pivotal moment in our history. They brought us closer to the moon than ever before, revealing secrets that reshaped our understanding of this celestial body. From the confirmation of the moon's formation through a cataclysmic collision to the discovery of its lack of atmosphere, these missions have broadened our knowledge and fueled our curiosity. This fascination did not end with Apollo. The lunar samples collected during these missions have provided invaluable insights into the moon's geology, unveiling its volcanic history and potential for resource exploration. These fragments of our celestial neighbor continue to be examined, offering fresh revelations about the moon and its past. Yet the moon's mysteries are far from fully uncovered. New missions, robotic probes, and plans for a sustainable moon base are taking us back to this celestial body. These ongoing efforts reflect our enduring fascination with the moon and our desire to further understand our place in the universe. As we stand on the brink of a new era of lunar exploration, we can only wonder what other secrets the moon holds. What will we discover? How will these findings shape our future? The answers lie in the stars, waiting for us to reach out and grasp them. Join us next time as we continue to unravel the lunar mysteries and expand our horizons beyond Earth. Don't forget to subscribe for more amazing videos like this. Happy exploring!